as promised. Now we're going to work through some examples. We're going to start on slide 7, and we will do this problem first, where a solution is prepared by dissolving 50.4 grams of sucrose, C12H22O11, in 0.332 kilograms of water. The final volume of our solution is 355 milliliters. Now let's calculate some different properties of the solution. All right. The first I'd like you to calculate is the molarity. Okay. If we're going to calculate our molarity, remember that molarity, M, was defined as the moles, right? The N of the solute per liters of solution. All right. Now, what is our solute in this problem? Well, we know that our solute is going to be what's being dissolved, right? So that's going to be our sucrose. Okay, now we need moles of sucrose. Okay, well, we have 50.4 grams of C12H22O11. We will convert that into moles using the molecular weight, right? So we'll get something in so many grams per mole. All right, the grams are going to go on the bottom and the mole goes on the top, just because we want to make sure that our grams are going to cancel. Okay, now the molecular weight is going to be 342.3 grams for every 1 mole of the sucrose. All right, which means that we will get 0.1472 moles of our sugar. Okay, so now we have 0.1472 moles of sucrose, so 0.1472 moles of our solute. Okay, and now we need our liters of solution. All right, we have kilograms of H2O. Okay, well, is H2O the solvent or the solution? It's just the solvent, so we're not going to worry about that. What information do we have about the solution? Well, we know that we have a volume of solution that is 355 milliliters. Okay, so I'm going to convert that into liters. All right, so that's going to be 0.355 liters. All right, again, because there are 1,000 milliliters in every liter. Okay, so now we take this, and that allows us to calculate our molarity, which is 0.415 molar. Okay, again, since we're calculating the molarity, it will be 0.415 molar. Okay, now the next thing that I want to calculate is going to be the molality with an L. Okay, now how was our molality defined? Well, we knew that that was our little m, and our molality was going to be equal to the moles of the solute per kilograms of solvent, right? Well, we've already calculated our moles of solute. That was our 0.1472, right? Because our solute was our sugar, okay? We have moles, all right, over our kilograms of solvent. Well, we know that water was our solvent in this case, and we have our kilograms of solvent. So we're just going to plug that in as 0.332 kilograms of our solvent. Okay, when we plug all of that in, we get a 0.443 molal solution with an L at the end, okay, which would be 0.443 molality. Okay? All right, now the next thing that I want us to calculate is our percent by mass, right? That's the same as our mass percent, it's just a different way of asking it. Okay, now to get our percent by mass, we're going to calculate our mass percent, which was our mass of A, right, over our mass total times 100, right? So here A was our solute, right? So since we're looking for our percent by mass of sucrose, okay, then that would be the mass of sucrose. Okay, so do we have our mass of the sucrose? Yes, we do. That's 50.4 grams. And our mass total, okay, we've got the kilograms of the water, okay, but in our solution, we're going to have the sucrose and the water, right? So that would be 50.4 plus, and I'm going to convert all of them into grams. So I'm going to have 332 grams, right? They all need to be the same unit. You could do it all in kilograms or all in grams, but they need to be the same unit. Okay, and then I multiply that by 100, and that gives me 13.2% by mass. You need to include the by mass. Don't forget about that. Okay? Again, your mass percent is mass of the species you're looking for over the mass total times 100. All right? Now, the next thing that I want to calculate is our mole fraction of the solute. Okay? Now, our mole fraction, if you remember, since we're doing it in the liquid, it will be an X. If we were doing it in the vapor, it would be a Y. Okay? And you guys can remember that from last semester. Okay? So, you have a mole fraction of solute in the liquid. So, we want X of our solute. Our solute in this case is sucrose. So, we have X of sucrose. And that is equal to our moles of sucrose all over our moles total. Okay? Now this one is not multiplied by 100. Okay? If you have a percent, you're going to multiply by 100. If you just have the fraction, you don't multiply by 100. All right? So we plug in our moles of sucrose over our moles total. Well, we have our moles of sucrose. All right? But we also are going to need our moles of water. Okay? So to calculate our moles of water, all right, we will take our 332 grams of water, right? There's roughly 18 grams per mole. Okay, so you're going to get 18.428 moles, give or take. And so you have 18.428. You then add that 18.428 plus your moles of that to get your moles total. So your mole fraction of sucrose is equal to, again, your moles of sucrose, which was 0.1472 moles, over your moles total, which was your moles of water, plus your moles of sucrose. Your moles of the sucrose were 0.1472. That's your sucrose. And then you're also going to add your moles of the water, which were 18.428 moles. All right. And that is going to equal 7.92 times 10 to the negative third. Again, that is 7.92 times 10 to the negative third. All right. Now, I am going to skip slide 8. That way you guys have some practice that you can do on your own. All right. If you have questions, feel free to Zoom me or shoot me an email, and I'll be happy to walk you through those problems. Okay? I like to do that. That way you guys have seen me work through an example. You guys work through it on your own, and then you can check your work later. All right? So we will jump to slide 9. Again, I will let you guys do slide 8 on your own. So slide 9 is what we're going to go to next. Here, a solution is prepared by dissolving 24.9 grams of glucose, right, Now, glucose is different than sucrose. Glucose is C6H12O6, and it gets dissolved in 375 grams of water. Okay. Also, the final volume of the solution is 392 milliliters. All right. Now, I'm going to then want you to calculate some of these properties. So calculate the molarity. Right? Well, the molarity, right, M was equal to moles of solute per kilogram of solvent. Okay? I'm also going to want you to calculate your molality. Okay? Your molality, little m, was equal to the moles of solute. Or I'm sorry, the molarity, that's not right. Molarity is equal to moles of solute over liters of solution. Right? Those of you who are sitting at home confused, right? The molarity is moles of solute over liters of solution, because what I had just defined was actually the molality. The molality is moles of the solute over kilograms of solvent. Make sure you have that right in your notes. Molality is moles of solute per kilogram of solvent. Okay? I also would like you to calculate the percent by mass of the solute. Okay? The way that we do that is by our mass percent. Okay? And our mass percent was the mass of the solute in this case, right? It's whatever we're looking for, the mass of the solute in this case, divided by the mass total. And because it's a percent, we're going to multiply by 100. All right. The next thing that I would like you to calculate is your mole fraction of the solute. Okay. To again get your mole fraction of the solute, that would be equal to your moles of solute over your moles total. All right. So in order to do this, we're going to need moles of different things, right? One of the first things that we need is our moles of the solute. Okay. So in order to get the moles of the solute, right, we're going to have to convert our grams of the solute into moles. Okay. So we have 24.9 grams of our solute, which was our sucrose, or sorry, in this case, our glucose. Glucose has a molecular weight of 180.15 grams per mole. Again, you're putting your grams on the bottom to cancel with your grams, and that will give you 0.1382 moles of C6H12O6. All right, so that's our moles. All right, do we have our liters of solution? Well, we have milliliters, so we can easily convert that. All right, so I'm going to plug in what I've just calculated, which is our moles, so 0.1382 moles of the solute, which in this case was our glucose because it dissolves, right? And then we need liters of solution, not of the water, but of the solution, okay? So then we're going to divide by 0.392 liters, where I converted my 392 milliliters into liters, all right, which gives me a molarity of 0.353 molar, all right? Now, the next thing I want to calculate is my molality. I have the moles of solute that I just calculated. All right, so I can plug that in, which is 0.1382 moles of the solute. All right, and then I need my kilograms of solvent. In this case, what's our solvent? Water is our solvent. So we're going to convert that into kilograms. All right, we have grams to convert from grams into kilograms. We divide by 1,000. So we have 0.375 kilograms of our solvent. This is going to give us a molality of 0.369 molal. All right, the next thing that I want to calculate is my mass of, or my percent by mass of the solute. Do I have the mass of the solute? I do. The mass of my solute is 24.9 grams. 24.9 grams, and then I need my mass total. Okay, so that means that I need to add my grams of the glucose and my grams of the water to get my total mass. So I'm going to take 24.9 grams plus, and since this is also in grams, I can add them together. So that's 375 grams. I'm going to multiply that by 100 to get 6.23% by mass. Again, don't forget to have the percent by mass because you could also have a percent by volume and they will be different numbers. Okay, now, next thing I want to calculate is the mole fraction of the solute. All right, again, we're going to calculate this by taking our moles of solute over our moles total. Now, our moles of solute, we calculated our moles of solute to be 0.1382, 0.1382. All right, that was our moles of solute. Now, we have our moles of solute, but we also are going to need our moles of solvent in order to add together to get our moles total, right? Because we have the moles of the glucose, but we need the moles of the water in order to get our total moles. All right, so moles of H2O. In order to get our moles of H2O, we're going to take our 375 grams. All right, how do we convert from grams into moles? By our molecular weight, right? So we have 18 grams per mole. We're going to put the 18 on the bottom with the grams because we want our grams to cancel, and that will allow us to convert into moles, giving us 20.814 moles of H2O. If I add 20.8 to 0.1, I'm just going to do 0.14. You would actually plug in all the numbers. All right, I'm just doing it as a shortcut. So that gives me my moles of solute, again, where I've just added my 20.814 to my 0.1382, right? So that we get our total moles. That means that my mole fraction of the solute, right, which in this case was our glucose, is equal to 6.6 times 10 to the negative third. All right, that would be how you work through the example on slide 9. All right, again, you know how much you guys like examples, so I'm going to run through another one. And also feel free to pause if you need a chance to write down and catch up. That's totally fine. All right, that's why we have the videos. I'm going to try to leave these up because I want you guys to go back and review them when you're studying for the exams and the quizzes, okay? These are going to be useful tools for you guys. All right? I want you guys to be successful. Again, if you have questions, feel free to reach out to me at any time. All right, now, slide 10. Okay, here we have a solution of hydrochloric acid is 36.0% by mass. Okay, and the solution has a density of 1.19 grams per milliliter of solution. Okay, now I want you to calculate your molarity, right? So if you're going to calculate molarity, molarity is defined as moles of, and if you notice the way that I'm addressing each of these different problems is, if I'm looking for molarity, I write down the equation. That's the very first thing that I do. So if I'm calculating molarity, molarity is equal to moles of solute per liters of solution. Okay? I write down that equation and then I try to figure out what I need to solve that equation. All right? The next thing that I want to calculate is the normality. Okay? Now, remember, normality was based on equivalence of species involved related to the molarity. Okay, so we're going to have to calculate our molarity before we can do the normality. All right, the next thing is going to be the molality. All right, now molality, that was our little m. Molality is equal to, or defined as, what? The moles of solute per kilograms of solvent. Not of solution, but of solvent. All right, the very next thing that it asks for is the mole fraction of the solute, okay, which in this case our solute is HCl and our solvent is water, okay. If you have an acid, okay, it's going to be dissolved in water, okay. Now, we have our mole fraction of solute. We need to define that, so the mole fraction of HCl is the moles of HCl over our moles total. Again, we are solving for the fraction, not the mass percent or the mole percent, so we're not multiplying by 100, okay? The fraction does not have that multiplication by 100, all right? So, now that we've got a lot of our equations defined, all right, we need to find the pieces that get plugged in, okay? So, for this type of problem, all right, the first thing that you're going to want to do is to find the moles of HCl, okay? So, what I would recommend that you do is I would recommend that if you see a percent by mass type problem, assume a mass, okay? So, your very first step is going to be assume a mass of solution. Okay, so if you assume a mass of solution, all right, let's say that we pick, the easiest one to do is usually 100 grams. Okay, so we've got 100 grams of total solution. Okay, so now we have 36% by mass. That means that 36% of this total solution is HCl. All right, so that means that I'm going to then say, for step 2, I'm going to multiply my percent, right, my mass percent, by that mass. Okay, so what you're going to do is you're going to take the 0.36 and you're going to multiply that by 100 grams. Okay, that's going to give you 36 grams of your solute. So that means that 36 of that 100 grams is HCl. So if 36 grams was the HCl, then that means you're going to subtract the 36 grams from your total, okay, to get how many grams are left over? 64 grams. That means that the rest of it was your water, right? If 100 grams is what your total solution was, and you found that you had 36 grams of HCl, then that means you have 64 grams of H2O, okay? So we have those two numbers, right? Using those, we can get our moles in a particular volume, okay? We also know that we have a grams of total solution, and we have a density for that solution, all right? So let's take our 100 grams. So step 4 is going to be to use the density to get the volume of the 100 grams. Okay, so we have 100 grams of solution, right? Here's our density. We want the grams to cancel, so they're going to go on the bottom. So we have 1.19 grams, and we have 1 milliliter on the top. This allows us to convert into volume of our solution. Okay, so now we have 0.084 liters, right, or 84 milliliters. Let's do that first. So we have 84 milliliters of solution, which is 0.084 liters of solution, right? Because we had 100 grams of solution, so we converted 100 grams of solution into liters of solution, all right? Now, that allows us to get our liters of solution. So that was what went on the bottom, so we have 0.084 liters. Again, we're doing all of this assuming that we have 100 grams of solution. We found that we had 36 grams of HCl, and we found that we had 64 grams of water, and we found that for that particular amount, we had 0.084 liters. All right? So, again, you're using an assumed mass to calculate properties in that solution using what you know about that solution. All right? So, now that we've got this, what else do we need to calculate our molarity? We need our moles of the solute. Right? As I said before, HCl, that's what's being dissolved in the water, so that's our solute. Okay? So, we can use our grams of HCl to get our moles of HCl. Right? So, step 5 is to calculate your moles of solute and solvent. Okay, I'm trying to work through steps so that way you guys have a procedure for how to set up these types of problems. All right, so solving for our solute first, we have 36 grams of HCl. All right, we're going to use our molecular weight. All right, and the molecular weight for our HCl is about 36.45 grams for every mole. So that gives you 0.987 moles of HCl. Okay, so our solute was HCl, so we have 0.981 moles, giving us a molarity of 11.75 molar. All right, now to calculate our normality, we had to use our full-time equivalents, right? So we were looking at our active species, right? So step 1 for normality, identify active species, right? Our active species is going to be the H+, and we have 1 H+. Okay, so we are going to take that 1 times and multiply it by our molarity, which was 11.75 molar. Okay, and that gave us 11.75 normal. All right, identify the active species, figure out how many you have, and use that number of however many you have and multiply it by your molarity to figure out your normality. All right, next thing is to calculate our molality. All right, we needed our moles of solute. Well, we know that. We just calculated it. It was 0.981 moles. And then we needed our kilograms of solvent. Okay, now we know that we had this many moles in 100 grams of total solution. All right, but the solution is not the same thing as our solvent. Our solvent was the water. So that means that we need to convert this into kilograms because our water was the solvent. So we have 0.068 kilograms, where again, I've just converted my 64 grams into kilograms. And now you can see that we get a molality of 15.4 molal. All right? Now, the last thing that we have to calculate is our mole fraction of the solute. Okay? And for that, we need our moles total. Right? We have our moles of HCl. That was 0.981 moles. All right? And we have 0.981 moles on the bottom, but we also need to add our moles of the water. Okay? So, we need to calculate our moles of the solvent, which is 64 grams. All right, our water is 18 grams per mole. Again, putting the grams on the bottom to cancel, which is going to give us it gives us 3.55 moles, and then I add 3.55 moles onto the bottom so that I get my moles total. Once I do that, then I see that my mole fraction of HCl is equal to 0.217. Right? So, as you can see, if we have the percent by mass and the density, we have to sort of follow a different set of steps in order to get out some of that information. So I would recommend that you guys work through this and try to understand each of the steps and work through some of those book problems in the back of the chapter, so that way you understand how to get the relevant properties of each solution using that information. All right? Again, when we have this type of system, right, where we're given our percent by mass, what we have to do is assume a total mass of solution and then base everything off of that assumption. Okay? Now, with that, that will conclude the examples that I had for today. All right? In the next video, we will be talking about intermolecular forces.